When you're creating basic character movement in Godot, something can seem a bit off at first. That's because most games add some form of acceleration to the player character to make the movement seem a bit more believable. In this tutorial, I'm going to show you how to create basic 2D platformer player movement with configurable acceleration. I'm also going to show you how to do the same in 3D, since the script for that will be very similar, just with an extra axis. Let's get to it. Starting with the 2D example, I've made a simple scene to test the character movement. I drew a small level to play around in using a tile map. I have a parallaxing textured polygon for the background. I also have the player, which is a kinematic body 2D node. The player contains a sprite, a collision shape matching the sprite, and a camera 2D so that the view will follow the player as they move around the level. Let's start by adding a script to the player node. Right-click it and choose Add Script. I'll name this script Player2D. Let's get rid of the default text in the file and start by adding in the physics process function. I will also add a return type of void, since we don't need the physics process function to return anything. To start the physics process, I want to first get the horizontal input of the player. I will create a new local variable to store this input in. I get the input using the input class's getAxis method. GetAxis takes a positive and a negative action as parameters. I've already made actions for the player controls from the project settings input map tab. You can add a new action by typing in its name and clicking Add. You can then bind any button you want to that action. We want to use the left and right action in our getAxis method. Next, we want to take this horizontal input value and multiply it by a speed value. I will create a new exported variable for the speed, so that it can be adjusted in the inspector for fine-tuning the feel of the movement. The values I'm using here are pretty high. This speed value equates to pixels per second. You will need to adjust them based on your project and the gameplay you are designing for. We need a variable to store the player's movement values in. I will create a new vector2 variable called movement vector for it. The .0 is to have values of 0 by default. We can set the movement vector's x value to be our horizontal input value. We can also set the movement vector's y value to be a gravity value. Let's also create a new export variable for the gravity. At this point, we can already move our player using the kinematic body's move and slide method. Let's give it the movement vector and a vector2 up for the up direction. We can now run the game using the play scene button or by simply pressing F6. We can move around using the left and right actions. We can also see that gravity is working. There's no acceleration yet though. Let's add that in now. Back in our script, I'm going to change the way the horizontal input is applied to our movement vector's x-axis. Instead of setting it directly, let's use the move toward method instead. This method takes a from, a to, and a delta parameter. It then moves the from value toward the to value by the delta amount. Let's use our movement vector's x-axis for the from value, the horizontal input for the to value, and the physics process delta value for the delta. This delta value is the time passed since last frame, and it can be used to make our player move at the same speed regardless of the game's frame rate. The delta value is very small though, and we want to be able to adjust the speed of our acceleration, so I'm going to create a new export variable, hsl, for horizontal acceleration, and multiply the delta by it. We can do a similar adjustment for the vertical movement. Let's set the movement vector's y-axis using another move toward method. Set the movement vector's y-axis as the from value, gravity as the to value, and the delta multiplied by a new vertical acceleration variable for the delta. At this point, we can also give our player the ability to jump. Let's create a new if condition that checks whether the jump action has just been pressed. I'm also going to check whether the player is on the floor, so you can't jump in the air. Inside this if statement, let's set the movement vector's y value to a new jump power variable. Make sure the jump power is negative to match the 2D coordinates up direction. There is one more important thing to do. The move and slide method returns our movement vector after doing its physics calculations on it. We need to apply this to our movement vector variable to make sure it's consistent with what's happening in the physics of the game. We can again test our game. Now our movement should be smoother thanks to the acceleration we added. Jumping and gravity should also work as expected. Now that we are happy with the 2D movement, let's move on to the 3D example. For the 3D example, I'm working with this scene. I've created a small level using CSG boxes. I also have a moving platform animated using an animation player. Moving platforms work well with kinematic bodies, just make sure to set the animation player's process mode to physics and the platform kinematic bodies sync to physics on. For the player node, I'm again using a kinematic body. Inside the player I have a mesh instance for the orange capsule, a capsule collision shape, and a camera that moves along with the player. Let's start by adding a script to the player node. I'm going to name this script Player 3D. For this script, we can get started by copy-pasting the Player 2D script. Let's go over to that script, select everything, copy, and replace the contents of the Player 3D script. To start, make sure that the script is extending the kinematic body class and not kinematic body 2D. Let's change the vector 2's to vector 3's, since we are working in 3D now. We also need to change the way that the horizontal input is received, since it has an extra axis now. Instead of reading the horizontal input directly, let's first create a vector 3 0 for it. Then let's set that vector 3's x-axis, using getAxis with the down and up actions. Let's do the same for the z-axis, using the left and right actions. Since we can now move diagonally, let's make sure that the player can't move faster that way, by limiting the horizontal input's length using limit length with the value of 1. You can also see the benefit of setting the type of our horizontal input as vector 3 to improve code suggestions. The move toward method we are using here is the global version that only works with floats. Let's change this to use the vector 3 classes version instead. For this version, the variable it's called on acts as the from value, so we only need to add the horizontal input as the to value and the delta. There is a problem here, however. Since we are using the move toward using all the axes of the vector 3, we also end up changing the y-axis. We want to manage the y-axis separately, and to ignore it here, let's just set the horizontal input's y-axis to be the movement vector's y-axis. The move toward for the y-axis works as it should, since the y is the up and down axis in 3D too. But we do need to change our gravity to be negative and our jump power to be positive, since the y-axis is flipped from the 2D example. Lastly, we should change the numbers that our exported variables use, since the 2D values are way too large for 3D. Now we can run our game. Everything should work as it did for the 2D example. We can move around and jump. The horizontal and vertical acceleration also makes the movement seem smooth. Riding the moving platform should also work perfectly. That pretty much concludes this tutorial. A few last notes. While this tutorial is meant for Godot 3.5, the project only needs minor modifications to work in Godot 4. There are some differences in how the new physics nodes work, for example. Also, for now we were just using custom values for the gravity, but you could also make use of the default gravity values in the project settings. This is useful if you want to match your player's physics to that of all the other physics objects in your game. And that's it. I'm planning on doing a follow-up tutorial where I show a few more features that you could add to the basic movement script we made here. I hope you learned something, or at least had fun watching this. If you have any questions, let me know in the comments. Please like the video and subscribe to support us in making more content like this, and thank you for watching.